Alright, so continuing on our lessons of the financial unit, we are going to be exploring something called present value today. So obviously I could give you the formula, but that's no fun. Well, the most fun part is actually deriving the formulas. So let's go ahead and do that. We have a person here, Ramona, and they hope to buy a house in 3 years. And an estimate that a down payment of $70,000 should be sufficient. She wants to know how much money to invest now at 6.25% of interest per annum, compounded annually to obtain this down payment. The money that Ramona invests now is called present value, or PV, of the investment. So one of the very cool tricks that I see most math teachers in school, the day school teachers, they do is this timeline thing. So this timeline right now doesn't seem that big to you, but obviously at one point when we start talking about the future value, it's really clear this timeline is going to help you figure out which way you're going. So whether you're currently saving for something in the future, or you're in the future and you're estimating, let's say, the things that you wanted to buy in the past and inflation rate and all of that, pretty useful. I think the timeline keeps you a little clearer, and many times some of the questions they don't even need the formula. You just use the timeline, and it's pretty intuitive. This unit is supposed to be intuitive, by the way. All right, what is the interest rate per compounding period for Ramona's investment? So that obviously we had 6.25% per annum. So I'm gonna go ahead and have a text box here. So A 6.25% per year. B. What expression on the timeline represents the amount of the investment for each of the following? So right now is obviously at the start. So I, so 1, so now PV after 1 year, it's gonna be PV times 1 plus 0.0065. After 2 years, it's gonna be PV times 1 plus 0.0625, square that. After 3 years, it's going to equal to PV multiplied by 1 plus 0.0625 to the third power. So we're picking up a pattern here. I hope you are. The power is changing, and also I'm pretty sure this you have to do 6.25 divided by 100%, so you get rid of the percent, so you get the rate. Whatever, does not really matter. So, what is the amount of the investment after 3 years? So basically, we just have to, do this. Wait, what is the amount of investment after 3 years? So, okay, never mind. So, pretty straightforward answer. So it's actually just $70,000 because that's how much we need. That's how much we need to buy the house. Therefore, that's how much our investment is desired to be after 3 years. Okay. All right. Let me make this text box bigger. Okay. Write a formula with the amount of C with the amount from C and the equivalent expression of B. So, I guess what you're trying to figure out is going to be PV 1 plus 0.0625 to 30. That's it. This is the equivalent expression. So this is our current value that we have, right? As it says. So the money Ramona invests now is the present value. So that's how much we have right now. And we're going to multiply this by a 6.25% interest rate for 3 years, and it's eventually going to reach $70,000. And now we need to calculate the present value to the nearest cent. So you can do that. Get yourself a calculator. So do that yourself. Alright, 2a. Starting with the value of PV as first term, list the values of Ramona's in a sequence. So basically what you want to do is, actually I will have to, I believe I will have to go ahead and do this. So I have to solve this because I need to use this for later, and we're going to do it to the third power. Divided by 1.199. So our answer should be around 58, 380, 382. They're set, so 0.98. Okay, so that is our value, and this value is going to multiply by 1.0625 every year. So let's go ahead and multiply that. So you will get 1 times 1.0625 again. You're going to go ahead and get 65908.91. And finally, you multiply by 1.0625 one last time, and you're going to get 70,028.22 cents. So this is all of the present values, well, all of the values in sequence. What type of sequence do these obviously form? Geometric, because you're as we are multiplying by the same factor every year. See, for the sequence representing this environment, so what is A? Our initial value, what is R? So A is equals to 5832.98, and R equals to 1.0625, which is our interest rate. Interest rate is our money to begin with. Alright, and D, do these values, use these values to write the nth term. So you can do that because yeah, you can do that. What do you notice about T4? So you go ahead and analyze all that. Analyze. 3. To determine the formula of present value, let PV be the present value or first term. A be the amount at the end of the investment. So let's go ahead and write the formula now. So PV is equal to times some sort of interest rate, 1 plus I, to the compounding period of N, and it's going to equal to investment amount. Substitute into the formula and So use a negative exponent to express the formula as a product. Whatever. So you will have to use the nth term sequence formula. By the end of the day, this is what you're going to be getting. Oh, I can't drag that. Sorry. This is what you are going to be getting. This formula right here, little pretty thing, it's going to be our formula that we're going to use. So present value, obviously this is this formula here, except we isolate it for present value. So PV is equal to A multiplied by 1 plus I to the power of negative n, because you divide it by that, so you move the power and have a negative. Simple basic arithmetics. So it's the same thing. Take a look. That is our pretty formula that we have derived from, the textbook. Write the formula for that. PV principle. So yeah, the rest is basically applying this formula, which obviously I'll give you a little bit of time to do right now. So pause the video, go ahead and do 4 and 5. Okay, I hope you have gave it a little try. It's a very simple formula, and just like all other math, it's formula, all other math in this unit, having a formula just basically means you already know how to do the problem. So the biggest part of this unit is actually never calculating this. It's always understanding the problem. So let's go ahead and let's see this. So do not read the example one, finding present value, blah, blah, blah. No. We are going to look at the problem and find out what's missing. So the grandparents would like to have $150,000 when they retire in 9 years. So our value at the end of this investment is going to be $150,000, and it's gonna take them 9 years. So the compounding period is gonna be 9. And we see that if they invest now at an interest of 5.75% per annum, compounding annually, so we do have 9 compounding periods because there is obviously 9 years and it's compounded per every annum. And our interest rate is going to be 5.75 divided by 100. Otherwise, it's 0.0575. So 0.0575. Okay, and now we can use our little formula. So what we want to know is our present value, and that's going to go ahead and equal to a over 1 plus I to the power of n. Let's go ahead and plug it in. So that's going to go ahead and give us $150,000 over 1 plus 0.575. Sorry, 0.0575. That would have been 50% to the ninth power. So go ahead and let's give that calculation a go. So I hope you're doing that yourself. Okay, so if you did the calculation, you would have got 90K, 90, so PV would equal to $90,000, 691.77 cents. So that is to the nearest cent. So most of your teacher will ask for the nearest cent simply because it's 2 sig figs. And in math, we don't really care about sig figs, so 2 is enough, more than enough. In science, maybe not, and it depends on the saturation in science, but in math, 2 is enough. Alright, let's go ahead and give this next problem a try. Now there's a multi-step problem. So finding the present value with interest compounded monthly. Okay, so we're changing it up a little bit, up in the spice. The Elmwood School Orchestra is planning a fundraising event to help finance a trip to England in 2 years. So we're planning 2 years ahead of time. The orchestra plans to invest the money from this event for 24 months in an account with interest for 4.5% per annum compounded monthly. So we're going to be having 24 compounding periods, which is very cool since we just got that. It's our first unknown variable. Now, interest rate, we all remember how to calculate the interest rate from this. We're going to take the per annum interest rate and we're going to divide it. Okay, so we're going to go ahead and do 4.5% divided by 100 first. And then we're going to divide it by 12. So 4.5 divided by 100, which is 0.045, divided by 12. So you're going to have 0.037. This is going to be your interest rate per month, obviously. And we are assuming it's constant per month. And it compounds at the end of the month. So the orchestra hopes to will provide $80,000. Sorry, $8,000. So how much does the orchestra need to raise to achieve this goal? The orchestra hopes money from Okay, so the orchestra needs to raise. Okay, so let's go ahead and find out the PV. So PV equals A over 1 plus I to the power of n. It's going to go ahead and give you 1 plus the 1 plus to the power of 24 and $8,000 over tiny number, which is gonna give you $7,312.68. Conclusion statement. Therefore, the orchestra need to have from this fundraising event. Okay, that is perfect. So we got that. Now let's do B. So how much do we need to earn from interest? Obviously 8,000 minus 7312.68. It's gonna go ahead and give you a number. Clearly, the number is 687.32. 7.32. Therefore, the orchestra needs to earn 687.32 bucks from interest to meet this $8,000 goal. Now, 8,000 is definitely worth it to go on a trip to England. Not gonna lie, but we still have to do the next question. Olivia is making arrangement to start her own business in 4 years. She believes she will need $26,000, and she compares investment plans. So 5.1% per annum compounded semi-annually, twice a year, or 4.9% per annum compounded quarterly, so 4 times a year. So let's go ahead and subdivide this. So plan A, 5.1% per annum and compounded semi-annually. While we will also have plan B of 4.9% per annum and compounded quarterly. Alright, so let's go ahead and do both of these. So I hope you can also pause and give this question a try. But I will be doing it here. So our N is going to be, so in 4 years, so semi-annually, so twice per year, so 8. And our interest rate is 5.1 divided by 100 divided by 2 per year, so 0.025. And our A is going to be $26,000. And PV equals A over 1 plus N, 1 plus I to the power of N equals to 1 plus 125 to the power of 8. And we're going to have 6,000 divided by that. So we're going to have 212,506.32 cents. Okay, so we just did one, and note that we do want the least amount of starting value. So let's go ahead and see this. Oh, not Quillbot. N equals quarterly, so we'll have 4 per year, so we'll have 16. And I is going to equal to 4.9 divided by 100 and then divided by 4 a year, so it's 0.012. Very small number, and A is still going to be 26,000. So PV is going to go ahead and equal to A over 1 plus I to the power of N. So let's go ahead and do that. So 1 plus I to the power of, so we're going to have 16, and 26 divided by that, it's going to give us 21,397.78 cents. Now, let's do the comparative analysis. Let's do the comparative analysis. So because as plan A requires $21,000, $21,256.32 to start, and plan B requires $21,397.78 to start, we would rather the plan with the lower amount of present value. Therefore, plan A is a better choice for us as it earns more money. Okay, and that is it for today's class. I hope you took some away. Your homework will be on page 522. There's some key concept there, and 523, 524. Textbook is in the comment section, and it's also in the class material that I sent at the start of the class. So if you need, go ahead and grab that and make sure you do your homework.